and welcome back. Now today I'm going to go through my smartphone charger with this thing here and the smoked glass, not glass, what is it, acrylic top here, coaster. Yeah, and I've got to do this video early. I mean, look at the time over there, 7:01 in the morning, because it's going to be a really, really hot one today, so I've got to get on. Okay, now the reason it's all a bit delayed this week is because of this flashing thing on top, which has got absolutely nothing to do with Arduino stuff at all. As you can see, it's plugged into my PICKit2 here. I've also got a 3, but I could not get it working under Windows 10. Found a solution, which I'll be telling you about in a future video, but my goodness, that was a day and a half of... Imagine a series of bricks. Nice brick thick wall, my head, bang, bang. Yeah, that's how it was. It was awful to get this to work. Eventually I thought, hang on, perhaps there's something wrong with the PICKit2, but I tried it under my virtual machine, which is a Windows 7, and it worked fine, so I knew it wasn't that. So anyway, I've managed to get the thing programmed again, and as you can see, lots of flashing LEDs. Great. Okay, enough of that though. That was just a by the way, why it's a little bit tardy, because I wanted to talk to you through the PCB construction of this, which was done by JLCPCB. JLCPCB offers custom PCBs with fast, reliable delivery. But today I want to talk about their SMT and PCB assembly from just $2. Let's have a look what that consists of, shall we? So as you can see here, the PCB and SMT assembly is available from $2. How do they do that? So normally there's a $7 setup fee, but in this case they're going to give you a voucher so you don't have to spend that money. Great, all you do is pay for your components. Simple. PCB SMT assembly from $2 from JLC PCB. Why don't you try them out now? Previously I probably showed you this board, which was all constructed at the time. Bits were all soldered on, like that was on there. The PIC micros in the middle, the Bluetooth thing, that one down there, was in here. And yeah, it was sort of okay, but there were a number of things wrong with it. And I thought, am I going to live with this, or am I going to actually put it right? So I thought, you know, put your hand in your pocket, because I had to pay for the replacement PCB by myself, of course. Let's do it properly, so that I'm, you know, proud of the result. And I am now, that one under there, which we'll have a closer look in a minute. But what are the things I did wrong? Believe me, I've got a big, long list here, which I'm gonna whiz through. Okay. So first of all, the cable, the USB cable, which is tied on the end here, so it's soldered in here, all right, soldered in there, and then tied with cable ties. Those holes were too small, even though I measured them. So you got to add a little bit of slack, haven't you? What else? This footprint was incorrect. That was my fault, because I put that footprint together, and it overlapped this one, which meant yeah, it as you can see, there's actually damage to the track there where I had to file it off. So that was moved up a bit. That was all okay. In hindsight though, I think I would have used SMD components for all these, not surface mount like this, but there we are. What else was there? Oh yeah, I said put this display, the one that you can't see yet because it's not switched on, that display there, I said put it at 45 degrees here so that you can read it nice, which worked great until I put the top cover on, and then it was hidden, would you believe, by the edge, the rather thick edge of this top acrylic coaster. So that didn't work too well. So now it's almost vertical, just coming out the edge like that. So yeah, what else? The Bluetooth module, this is the HC05 module. I had terrible trouble getting it to well, not pair up, to use the AT commands on, because it used different AT commands. That footprint is in fact reversed. That should have gone flipped the other side of the board, so I've corrected that. And yeah, this ICSP port, which I tend to put on all my boards now so I can program them, isn't really needed on this particular board because I'm using a Pro Mini. What do I mean by that? Well, here's, oh no, that's the Watchdog. Oh yeah, Watchdog Timer PCB. That's for a future video though, right? There's lots to talk about on that one. Right, there's my Bluetooth Mini, and there's my FTDI. So when that is on the circuit board, I might as well just use an FTDI programmer with the bootloader, because it just doesn't make any difference in this project. It's only when you don't want a bootloader that the ICSP one really comes into its own. So yeah, I needn't have bothered putting that on there with all the work that entailed. And that's probably about it. Now, I think I'm going to plug this in next so you can see exactly how it looks. Obviously, I've got this acrylic coaster on top, which it's only held in with 2 screws at the minute, so I'll take those out as well, and then we'll have a discussion of what's going on inside. Okay, right, I've just plugged it in, taken the top panel off. This is, in fact, an acrylic coaster. I can't remember how many mil deep they are, but they're just acrylic coasters. They're pretty cheap from eBay. They come with little tiny transparent feet on them, which you can just peel off and then clear up the gunky glue afterwards. But I find they work very well for projects like this. This one here is black, as you can see, non-transparent, totally opaque. So that's the base, and then this one is sort of a smoked grey, which goes on top. Now that was always my intention, because this is the way I constructed my Home Alone project as well, because people can see all the LEDs and the electronics underneath, and I don't know, people are just interested in it, you know, they like to see it, like, oh, what's that, you know, rather than being hidden away in a box, never to be seen again. And there is a certain, you know, beauty of seeing things like this, isn't there? Anyway, we'll move the lid out of the way. Right, so on this one then, so the 219 current measurer has been moved up a bit to leave a bit more room down here. As it happens, I don't need it because I'm having this screen vertically. I have put a flashy LED in here, which I haven't actually used yet, and a beeper, just to sort of draw my attention to the fact that perhaps I haven't plugged it in my phone. I haven't used that yet either. The thing I haven't completed about this is the code. In my code, there are big things it says to do. Do something with the Bluetooth LED here and do something with the red LED there, but that's all for the future, because coding's easy, isn't it? Once you've got the hardware done, it's easy. As you can see, I have actually connected up to the ICSP here, but I don't know whether I'm going to use that or that. It doesn't make any difference, to be quite honest. The Bluetooth adapter, this is an HC05. The difference between the HC05 and the HC06 is that if I show you the other one underneath, right, so on here you can see that there's a state pin, yeah, which means am I connected or not, and it will tell you. All right, so that state is connected internally on one of these castellated holes, except on here it wasn't actually soldered up. So when I plugged it all in, it says no, you're not connected. So I had to solder one of these pins up the side here, and Martin Curry's website assisted me in telling me exactly which pin it was. It might have been over here or both, can't remember now. But anyway, those castellated holes, which look like half holes on the edge of your board, I keep meaning to make one, but I haven't got around to it yet. I might do. So that once that was done, it all sprang into life. The cable tie is all fitted this time, and yeah, and as you can see, I've actually hardwired the cables into the board, so they're soldered directly to the board rather than on pins. I was going to put header pins on, you know, a bit like the ones we use for that, or this in fact, and I thought, well, why? It keeps it nice and flat this way, so I left it. Yeah, the USB cable is a standard USB cable that I've just simply cut, because if you remember, I didn't want any resistance that stops the charging current. And this particular one, although it's got a flashy light on it, it's actually magnetic. So it connects to the bottom of my phone. You can buy these, you know, fairly cheaply, but this one is only for charging. It won't allow data. You can get them with data as well, but not round. And as you can see, look, it really wants to snap to that. It really is quite powerful. Yeah, look, it's like it's got a mind of its own. It really does want to snap. And then, of course, when you want to answer your phone, you just whip it off without taking out your USB socket while you're doing it. So that was always the plan for that. As I said, the SSD 1306 screen, you can have these for about, I think it's like $2.30, $2.40, something in that region. And I thought, do you know what? When I was testing this, I kept looking at the serial output from here, you know, the serial print statements, to find out what was going on, rather than any LED statuses that I sort of planned to put in. All down here you can put LEDs in with series resistors, and I thought, well, if I'm so interested in what's coming out of the serial port, why don't I display something on a screen here? Bit once again like I did for the Home Alone project. So that's what I've done now. So it's a fairly late decision to put that on there. But having made that decision, A, I'm very glad that I did, and B, it's something I'll consider in the future, because these screens are pretty cheap, and if you don't like that particular shape, you can get them more in the shape of that Pro Micro, so slightly bigger. And the amount of information you can display on one of those screens is phenomenal, really, depending on what font you use, obviously. But I mean, the fact it can display what's going on can really help in debugging programs as well as giving you the comfort factor that, oh yes, everything's working as you'd expect it to work. So I think that was a good decision. Anything else underneath? I don't think so. No. Oh yeah, well, the beeper, I've put that in. It's not wired up to the code yet, nor is that LED, because sometimes I have the phone nearby and I've just answered a message or something, and then I forget to connect it up, and I think I might put a little beep every now and again to say, oi, you haven't connected your phone up. I put a message in here as well in the screen, but I think a little beep might come in useful. This isn't very loud, it's a little tiny one. I did test it out on another board, and I think it would do the business. Obviously, if this was being used in an office environment, you certainly don't want it beeping and burping and all the rest of it, annoy your colleagues, wouldn't it? So it's going to be fairly quiet. Discreet, I think, is the word we're looking for. Well, let's look at the thing running with the code that I've got so far. So at the moment, because the code isn't complete, there's nothing on the screen there, even though it's switched on. Because I haven't connected, shown by that flashy LED on the HC05, nothing's happening at the moment. Obviously, I'll have to put something on here to say connect the app, basically. So what we do, let me just get my phone sorted out. Right, so on the app, I can't believe it's 7:14 in the morning. Anyway, smartphone charger then, which hasn't changed, incidentally. Hasn't changed since I've done it, but it will change eventually. One of the changes I need to make is because this sends out a heartbeat to here every minute to say, I'm still alive, I'm still working. Oh, look, we've connected straight away. Look, connected. As soon as you fire it up, it's saying you're not, well, you should be charging, but you're not. What this does is send out a heartbeat message to here every minute, which I did while I was testing, just to say, I'm still here, I'm still alive. So it sends down a message, basically, rather than all the stats to here. But what that does, from the phone's perspective, is that it doesn't let the phone go to sleep. Now, that's not a problem if you're charging or you've got it connected. But of course, once you're not charging, you've reached whatever predetermined level of charging you want, then Android sometimes says, oi, this is a high power usage thing, it doesn't let me sleep. Well, no, let me clarify. This doesn't use a lot of power, but by not allowing the phone to go to sleep when you've switched it off, then when the screen's dead, basically, like that, it should go to sleep, and all your apps will go to sleep and only wake up periodically. Well, that particular app is not allowing the phone to go to sleep, so that's something I might have to sort out. Right, so on here, on the app then, I've said charge up until 95% of the battery, and then stop charging until the battery sinks down to 90%, and then start charging up. So it'll basically oscillate between those two levels. Some various options here. It can beep and vibrate, and it can show a little battery level alert. It's a little toast message that comes up down here. That was all done for debugging, but sometimes they're useful just to have. So if I connect this up now, you'll see that the charge value down there on the desk will change. There it goes. Now, that's a rolling average. That amount. I've got 20 entries in the matrix to say, good Lord, look, over an amp. I've got 20 entries, and it's a rolling average for 20 samples, right? And this is sampling, that one, the 219 is sampling every however long, I can't remember because it's so long since I wrote the code. But what I've tried to do is pre-populate the matrix when it's empty, this to the first time you do it, or if you come off charge like that. So it's obviously sinking down now because all we're doing is updating zeros into that table. So the average is going to go down and down and down and down. When it does that, what I want to do, when I snap back on, I want that to be pre-populated. As you saw there, it went straight up to over the amp, but it doesn't always do that, so I've got it in the wrong place in the code. So that's something that I'll be looking at. Running in the background is fine, just hit that button, or that one down the bottom. Let me do that again. So obviously to put any app in the background, you can just hit that that middle button, the round one. It's in the background, that's fine, and that will just keep going. Now the idea of the coaster on top is that I can then put my phone charger, this one here, on that, and that's how it will sit. So you can see now this display. You can't see the flashy and the lights underneath, but I guess we don't need that because it will tell me when it's not connected now. So if I were to now disconnect from here, so call it up and actually come out of the app, yes, I do want to exit, and flashy, not connected, it says. Woohoo. So at least I've got a message in the right place for that. So that's good. And as I say, this will all be sorted out, made a bit more professional as time goes on. The code for the phone hasn't changed since I did it. You know, well, there was 2 or 3 iterations, weren't there? I need to look at how often I can wake up the phone to send a heartbeat message back to this unit to say, I'm still here, don't worry, I'm still here, without the phone complaining that it can't go into sleep mode. So that's sort of an Android-y thing, and I need to get my head around that. Just a bit of information, isn't it? And of course, the reason it sends a heartbeat every minute, once again, that sort of debugging mode, isn't it? Whilst I was creating all this, you don't wait forever, do you? So I said, oh, minutes, fine. We'll just send something every minute, and that'll be good. But of course, in real life, when you know it's working like this now, we could send stuff back every 5 minutes, probably. Yeah, 5 minutes. So that's something else I need to look at. But as I say, coding is, well, I don't want to use the word easy. I find it comes easy to me, but then again, I'm a professional developer. But even so, once you've got the hardware nailed down tight, which I believe I have now, then you can put it all together and tweak the code as time goes on. You think, oh no, that bit doesn't quite work. Or I've forgotten, like on this one, when I first plug it in, nothing shows on the screen. You think, okay, I need to look at that and do it slowly and methodically, and it all sort of builds, doesn't it, upon itself, until you get to the point you go, that's it, it's done. Done, as my previous development manager used to say. It's a long story, but short. Every programmer or developer in the world will reply to, has that project been finished now? Have you done your bit? And he goes, yeah, I've done it. I've just got to, so it's not done then. Oh, but it is done. Yeah, it is done. I've just got to tidy up the front. Well, it's not done then, is it? And the expression that my development manager used was done. All right. Until it was done, 0 work to do on it, it wasn't done. And you couldn't hand it over to the next stage, you know, the business analyst or whatever, to check it out, make sure it conforms to spec, things like that. So done is the absolute nothing more to do. Not anything. Not I've just got to, no, nothing. And that's obviously the mindset I'm working up. This is nowhere near done because I've got the code to write for that. Probably got to sort the code out for this. So it's in an advanced state of preparation, but it most certainly is not done. Well, what I'll do, I'll show you where I got some of these bits. Although there's a salutary lesson. If you notice, the INA219 DC current detector on here is a different board to the one on here. Look how small this one is compared to that blue one. But they look on screen the same, but they're not. So luckily that one did fit, otherwise I've had to use one of these little tiny purple ones, which is quite a bit smaller actually. Now this is the INA219 current sensor, which I did a whole video about, but that's what I've used now in this phone charger. But if you look here, they're not that expensive. $4.82. Okay, it's not cheap either, but it is really, really good and really accurate, and you can program this, or at least set various parameters to this via I2C, and yeah, it really is great. But beware, if you notice the one over here, look, this is the purple one, and it's smaller than one of these blue ones. Okay, so if you're getting a footprint, they are not the same, as I found out to my cost. So just bear in mind that. That's 5 pieces for $12.20. That's much better value, isn't it, than a single one? Banggood know how to make you buy more, don't they? Okay, that's that. Now the Bluetooth device, beware. Right, so this is the standard HC05 Bluetooth device that I have in my product at the moment. It always comes with this plastic thing on it. I don't quite know why. I always take that off. The reset button's up here. Now, beware. I say beware because I bought some of these. And these are known as SPCC Bluetooth serial adapter, and it's supposed to replace HC05 or HC06. But let me get a bigger picture for this one. Now, the first thing you notice there on the bigger picture is that there's no reset button. The reset button should be there, and it's not. So I'm thinking, how do you ever set this into command mode so you can use an FTDI USB to serial device to connect to it and tell it what to do? You know, change the baud rate, rename it, that sort of thing. And well, I plugged mine in, and I was bewildered. And I tried connecting those button pads, that one and that one together, to sort of set it into command mode, if you like. No joy. So I've just put those to one side, dragged out a new HC05. Yes, this is cheaper, but my goodness, it better work eventually, or I'm going to burn them on air, I think. Yeah, so be aware of those. I would say stick with the tried and trusted HC05 version. At least we know that works. So here we have the SSD 1306 display in this format, so the long, thin format. You connect to it via I2C. It's an absolute doddle to use. And Adafruit has a library that allows you to write to it. I think it was Adafruit. Might have been RoboDen. Whatever. Now, if you don't like that format, how much are they first? $3.09. That's not each, is it? We can get 3 pieces for $7.13. Maybe it is. Maybe it is. Let's have a look. Right. So that's the $6.42. If you get it directly from the UK, I would say that's expensive. You can get 2 of these from Amazon for about a £5 or £6 or something like that. So from China, let's see how much it costs. $3.09, but that's on promotion until the end of June, which is only about a week away. But I find it's good. Just for that little tiny display you might want, just to allow debugging what the program's doing at the moment. It's the sort of thing I used to build into my PIC projects, funnily enough. I had a mobile display unit. Because I couldn't afford a display unit like this for each project, I wired it all up and had it via a jack plug. So on each of the projects, you could just whack in this little display unit, which is basically one of these connected to that jack plug, plug it in, and all the stuff that's coming out the serial would suddenly be displayed, and you could find out exactly what your beehive counter was doing or not doing. So yeah, at that price, that's not bad. But shipping $2.32. Look, that's a killer, isn't it? That's why I say look around a bit now. There's AliExpress. I'm not sure they ever did free shipping. Occasionally, but not very often. So look around AliExpress. You might have to buy 2 or 3 in one go to make it worthwhile, but you know, it's an alternative, isn't it? eBay, of course, although from the UK I find them quite expensive. And look at the big boys as well. You know, DigiKey, Mauser, RS Components, people like that. You never know what price they're going to have. So yeah, always useful to do a bit of a market scan before you buy. But that's not bad actually. Right, now I used a Pro Mini in this project because it was small. And what is a Pro Mini? A Pro Mini is exactly the same as an Arduino Uno or a Nano without the USB interface bit. Right? Now, if you're going to program via ICSP anyway, you don't need it. And even if you did, a bit like what I showed, you just use an FTDI to connect to the pins at the back and you're away. Now, how much do these cost? Well, this is 5 pieces for $12.97. I think that's probably more local. Shall we have a look? Yeah, now this is an interesting thing actually. Look, you get 5 pieces for $14.65 if you buy directly from the UK. Now obviously it's showing me UK stuff because that's where I live, but it might show you stuff from the States or Australia or wherever. Now $14.65, and you do get free shipping. Now there's a thing you don't see very often. So if I was to buy these from China, thinking, oh, they're bound to be cheaper from China. Look, $12.97 from China plus $2.20 on top of that. So actually it makes it more expensive, and then you've got the 2, 3, 4 week delay. So yeah, sometimes it's better to pay that tiny bit more up front and get free shipping and almost immediate delivery. Yeah. But regarding the Pro Mini, don't confuse it with the Pro Micro, right? Very different kettle of fish. The Pro Mini is effectively an ATmega 328p on this little tiny board. Oh, lost it now. There it is. On that little tiny board with everything that you need on it, apart from the USB interface. I mean, it's not a million miles away from the one I designed. Do you remember that little tiny thin one? That was everything to do. That was an Arduino Uno, except in a very slim breadboard-friendly format. So, and this is the same. So yeah, I'd say if you're thinking about something small, use one of these. If you're not so bothered, use a nano. I don't know why anybody would ever use a full-sized Uno, because you don't get any more pins as far as I'm aware. Well, you don't, no, because all the pins here are accessible. Yeah, so if I had to use something, it'd be a nano, and if I wanted something smaller than a nano, it'd be a Pro Mini. Yeah, interesting that, isn't it? Right, so this is the coaster that I bought. Well, not that pink one, obviously. They do lots and lots of colours. You can't. There's a scrollable list I'm going up and down here. You can't see it, never mind, but there's lots. Just look for square acrylic coaster on eBay. This is a UK site, admittedly, but you'll see these, and they come with little tiny plastic feet you can just peel off, only stick on things. Then you can use them in your product. Now, the cable that I'm using, the fast charging cable. Right, this is the fast charging cable. £2.59. And you can select, so it's a micro USB I got. Colour I had was red. The cable length was 1 metre. You can have it more. You're not seeing the drop down boxes again. Never mind. Compatible for other Android phone. Oh, $3.99. It's gone up. Wonder why. What did I do? Well, anyway, that's the cable I bought. And as you can see, it's got this bit at the top here that you plug into your phone, that stays in your phone, and then this bit here. That snaps to it magnetically, and very good it is too. And that certainly, it was, well, the magnetic feature of this cable is great anyway, but for this particular project it really come into its own. $3.99 for that USB cable, but it does say fast charging, and I guess it is, yeah. And as you saw, it allows over 1 amp to charge into my phone, which is pretty good for a standard phone charger. Okay, I think we're done with all the products now. The code hasn't changed, but what I'm going to do is put the code up on my GitHub with a special README, so it'll be in a folder now, not just directly on the GitHub. And as the versions increment, as I go, right, this is a stable version, I'll put a fixed list of all the things I've done to change the code on here, and this one as well. To download the code for your phone, Android phone, you're going to have to allow programs from unauthorized sources, because if there's anybody who's unauthorized, I'm it. Okay, so when you download, Android will complain. It goes, whoa, this is not from the Play Store, is it? What do you think you're doing putting it on here? You'll have to change the setting if you want to allow this to be installed, which of course what I have to do for myself here as well. But you can allow it and then switch it back on again, so that you're protected against unauthorized installation, but you definitely want to get that one installed. I did look at putting stuff on the Play Store, but it's a convoluted process, frankly, for this one-off. If I ever get to that stage, you'll find out, but I somehow doubt it. And you have to pay money, would you believe, to Google to register you're going to do it. So, money, 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 eh? Right, okay, I've realised now, all this time after speaking, I've left that blinky thing running at the back, haven't I? I hope that wasn't too distracting, but believe me, that took a day and a half to get my PICKit2 up and running again. And, well, as we're here, let me just show you the actual thing running. There we are, there's the thing actually running now, and this version is by this chap here from Vietnam. I can't even pronounce that. Ngo Hong Kuong, something like that. Anyway, he wrote, or he tweaked both the code for PICKit2 and PICKit3 to run under Windows 10, because so many people were having problems. As I say, a day and a half I spent on this before I discovered him and his website where you can get this, and he's written a whole thing about it. Now, as you can see here, what's that? You can't read Vietnamese. Let me translate for you. Right, there we are. Good old Google, eh? So what that tells you is how he's done it, and there's a couple of videos even, and down the bottom you can download it, I think, somewhere, whatever. Oh yeah, there's my comment. I thought, I'm so pleased at getting my PICKit2 running that I had to send him a little message saying thank you very much. I even also translated it via Google Translate, obviously, into Vietnamese. So yeah, so that's I know this is a total aside to anything else, but yeah, if you got a PICKit2 and you're into PIC chips, you definitely need this. Right, we're done here. I'm going to put all this back together, put all the screws in this time, and put this on top of it and start changing the code, I think, yeah, as time permits. So yeah, great. Okay, that's it. A bit of a rushed one. Look at the time, 7:32. That means I've been doing this for half an hour already. Sorry about that. I know I keep trying to bring the time down. Don't forget, you can watch the Bacon Bites series of beginner videos that really talk about things from an Arduino's perspective and how the Arduino interacts with various components. So far you've got resistors, capacitors, transistors, the next one will be MOSFETs. They seem to be well received, so yeah, do look at those if you're a beginner and you're a little bit unsure about how those things all work. And yeah, great, thanks for watching. Comments down below please, always good to tell YouTube that it was worth watching, and see you in the next video. I hope you're finding these videos useful and interesting. There are plenty more videos to choose, and a couple are shown below. And if you'd like to subscribe to this channel, just click on my picture below and enjoy the rest of the videos. Thanks for watching.